Yeah, question 15. We have the question, find the magnitude of the following two vectors, A and B. And we have the vector A, we have the value here, and we have the vector B also. Then the B part, we are told to find the angle to the nearest degree between the vectors A and B. So let's go straight to the solution. If you want to find the magnitude of a vector, it's very simple. The magnitude of a vector has this symbol. Just put a line across that vector equal to square root. And then you begin to write, take the square of the coefficient of those unit vectors, your I, J, K, we call them unit vectors. Okay, so just take the coefficient of each of them and you square that. Take the coefficient of your unit vector and square it, plus the second one, 7 squared, plus the third one, minus 9 squared. So that's our magnitude. Okay, so that's how you do it. Then we can get calculator and get the value. So that will be root 530. This is root 530. Then for the B, do likewise also square roots. The coefficient of your unit vector, they are 4. That will be 4 squared plus minus 8 squared, then plus 4 squared. So that's what we have. We begin to take the coefficient of your unit vector for I unit vector. The coefficient is 4. Square that, then plus the next value. Coefficient is what? Minus 8. Square that also, then plus coefficient of your unit vector k. That's 4. That's that. Square that. So that's the on magnitude. So that will give you 4 root 6. You take your calculator. Then, so that's that on these A parts. The B part, we want to find the angle between the vectors. So if you want to find the angle, we have a formula for that. A dot B, the dot product of A and B will be equal to what? A magnitude and B magnitude, and then cos theta. So we can take this, we can make this cos theta as a subject. Cos theta will now become A dot B, the dot product of the A and B, over A magnitude and B magnitude. So let's put the vector there. Vector A, vector A, this. Okay. So let's get the dot product of that. We have vector A. Let's find the coefficient. We have the coefficient, and then we have 20. For A, we have 20. We have 7. We have what? Minus 9. And then dot. The vector B, we have 4. Minus 8. We have 4. So I'm writing it in the column form. And then that will what? Root 530 times root what? 4 root 6. So that's what we have. Then when you are doing dot product, it's very simple. We are only multiplying the coefficient. Here is of I, unit vector is 20, times the other I. Okay, times 4. So that will be 20 times 4. And that will be equal to what? That will be equal to cos theta equal to 80 plus 7 times minus 8. That's minus 56. And then minus 9 times 4. That's minus 36. All over square root of what? 530 times what? 4 root 6. So theta will become inverse cos arc cos whatever this expression here. Okay? And you get your value. Okay? 5 degree. So approximately that's 93. Okay, degree. So that's that on that question. Okay. The only thing I want to mention for the dot product when you are doing a dot B is very simple. What we are doing is we are only multiplying those ones that are unit vector I, the coefficient multiplied together, 20 times 4, that's 80, then plus. For J, unit vector, the attachment, the coefficient is 7 here, is 80. Multiply this one and this one together. That's minus what? Minus 56. And then finally do likewise also. Minus 9 times plus 4. That's minus 36. All over your magnitude. So that's what we've done there for the question 16. Okay, which is the last question for this particular episode of this exam. Okay, this is the for this particular episode. Find a vector that is orthogonal to this vector and this vector. Okay, so when you want to find a vector that is orthogonal, what we're going to do the cross product, and that will be and then we're going to use the method of determinants. Okay, the unit vector, we write it first, ijk. Okay, that's solution. Then the coefficient of those vector, the unit vector here, the coefficient of I as a unit vector is 9. You write it, you put it under this I. For J, the coefficient is what? 18. For K, the coefficient is what? 4. Do likewise for the second vector. That's 7 minus 2 and 11. So we're using determinants to get the orthogonality. So we have I. Do your cross this. I'm using the horizontal row. I'm using the first row. Okay, the first horizontal line to do my determinants. So I have 18. I have 4. I have minus 2. I have 11. Then followed by minus j. Okay, do the same thing also. Cross the vertical and the horizontal. So I have 9, 7, 4, 11. And then the last one, the k, unit vector k. Okay, do the same thing also. Cross that vertical and horizontal. So I have 9, 18, 7, minus 2. So let's get the value. So that will be I into bracket. This one times this one. 18 times 11, that's 198. Minus 198. Minus 2 times, 18 times 11, sorry. 18 times 11, that's 198. Then minus 2 times 4, that's minus 8. Minus 8, that's plus 8. Minus j, that's 11 times 9, that's 99. Minus 4 times 7 times 4, 28. Then plus k into brackets. 9 times minus 2, minus 18. And then 7 times 18, that's minus 126. 8 plus 8, that's 206. 206i. Followed by 99 minus 28, that's 71. Minus 71 j. And then followed by, that's minus 144. 144. Okay. So, and you can write it in the column, in vertical form, in column form, in vertical form. That will be 206 minus 71 and minus 144. So that's that on finding the vector that is orthogonal to those two vectors. Just use your determinant method and get your answer. Okay, and you can also check whether you are right or not. Okay, you can check. How do you check? Very simple. 206, just do the 206 minus 71 minus 144. Okay, do the dot product of your answer to each of those vectors, which is what? 9, 18, 4. If you do the dot product, that will give you 0, and that confirms the orthogonality. Okay, you can check that. I will only do one, that will be 0. Then the second one, do the same thing also. 206 minus 71 minus 144. Okay, the dot product, the second vector, that's 7 minus 2, 11. So let's do one of them. So 206 times 7, That's a 1, 1, 1, 1, 4, 2. And then that will be 2 times this. That's a 1 plus 1, 4, 2. And then minus 144 times 11. That's a minus 1584. Let's check that. Yeah, that's 0. That's 0. So that confirms the orthogonality. So do the same thing also for this one. Just to check. It's not necessary your solution stop here. Just to check the orthogonality. If they are orthogonal, that vector you get here, dots, each of those vector must get, do the dot product, must give you 0.